The universe we know often feels like the only possible reality, a singular timeline where events unfold one after the other, locked in place. But what if that assumption is completely wrong? What if reality isn't a single thread at all, but a vast web of countless possibilities, each one branching into its own universe? This is the unsettling idea behind the concept of parallel universes. And while it has been the stuff of science fiction for decades, the foundations of the theory come directly from modern physics itself. To understand where the idea began, we have to go back to the strange world of quantum mechanics. Quantum mechanics is the science of the very small particles so tiny that they don't behave in the predictable way we expect. Instead of moving in straight lines or having definite positions, they exist in probabilities. They can be in multiple states at once, a phenomenon called superposition. It's only when they are observed or measured that they appear to collapse into one outcome. This bizarre fact led physicists to ask, collapse into which outcome and why? In the 1950s, a young physicist named Hugh Everett offered a radical answer. Instead of believing that the particle randomly picks one outcome and discards the rest, Everett suggested that all possible outcomes happen, just not in the same universe. Every time a particle has multiple possibilities, reality splits, and each possibility unfolds in its own universe. This idea became known as the many worlds interpretation. Think about the implications for everyday life. Imagine you're standing at a crossroads and must decide whether to take a job in another city or stay where you are. In Everett's model, you don't just choose one, both outcomes occur. In one universe, you move away and live an entirely different life, while in another, you stay and follow the path you know. Both versions of you exist, each believing they are the only real one, completely unaware of the other. Scale that up to every decision made by every human being, and the result is staggering. An endless branching tree of realities, each as real as the one you're experiencing right now. What makes Everett's idea so fascinating is that it wasn't invented as a science fiction story. It was a serious attempt to solve one of quantum mechanics' most confusing problems. The double-slit experiment is a classic example. When scientists shoot particles like electrons at two slits, they create an interference pattern, as if the particles acted like waves and went through both slits at once. But the moment you observe which slit the particle passes through, the interference disappears, and it behaves like a particle. Some argue this bizarre shift only makes sense if the electron goes through one slit in our universe, while in another parallel universe, it goes through the other slit. The interference pattern is the result of these universes briefly overlapping. At first, Everett's theory was dismissed as too wild. Most physicists preferred to believe in the Copenhagen interpretation, which claimed the act of observation itself forces the universe to pick a single outcome. But over the decades, as more experiments revealed how truly strange quantum particles behave, Everett's many worlds gained a cult following among scientists. Some now argue it may be the most straightforward explanation. Reality doesn't collapse into one outcome. It simply branches endlessly in ways we can barely imagine. The implications go far beyond physics. If every possibility creates a new universe, then there are infinite versions of you, living out infinite lives. In some universes, your life is almost identical, with only the smallest details changed. In others, the differences are enormous. Entire histories might have unfolded differently. Wars could have been won or lost by different sides. Nations could have risen or fallen. Technologies might have advanced centuries earlier or later. Somewhere, perhaps, there is a world where humans never even evolved, and another where civilizations stretch across the stars. For most of us, the idea feels too big to grasp, like trying to imagine infinity itself. But that's exactly what makes it so compelling. If Everett was right, then parallel universes aren't just a fantasy. They are real, they already exist, and we are part of them whether we realize it or not. Our everyday lives, every choice, every chance event, every flip of a coin could be creating countless new universes in every passing moment. And if that's true, then this universe is just one branch among an endless forest of possibilities. Which raises the question, are there ways to find evidence of these other universes, or are they forever beyond our reach? If Everett's quantum many worlds gives us one version of parallel universes, cosmology provides another one that emerges not from particle physics, but from the very structure of space itself. Modern science suggests that the universe may be far larger than anything we can observe, possibly even infinite. And if it truly is infinite, then the idea of parallel universes becomes not just possible, but inevitable. Here, why? In an infinite universe, matter must eventually repeat. There are only so many possible ways to arrange particles, atoms, and molecules. Eventually, across unimaginable distances, those arrangements will duplicate. That means somewhere out there, unimaginably far away, there could be another region of space identical to ours, containing an Earth that looks exactly like this one, with people who look and act exactly like you, watching this same video. And just a little further beyond, there could be a version that is slightly different. Maybe your name is spelled differently, or a historical event turned out another way. In an infinite canvas, all possibilities are painted somewhere. This isn't just speculation. The mathematics of cosmology, especially when applied to the theory of cosmic inflation, opens the door to the multiverse. Inflation suggests that right after the Big Bang, the universe expanded at a speed faster than light. That expansion may not have stopped everywhere at once. Instead, different regions of space could have bubbled into their own universes, each with different laws of physics. Imagine boiling water, where bubbles constantly form and separate. Only instead of bubbles of steam, these are entire universes, sealed off from one another by cosmic boundaries. This bubble universe model is one of the most widely discussed versions of the multiverse. In one bubble, gravity might be slightly weaker, allowing stars to live longer. In another, atoms may never form, leading to a universe of pure radiation. In yet another, chemistry might be so different that life as we know it could never exist. Our universe, with its delicate balance of forces, would simply be one bubble among countless others, lucky enough to allow galaxies, planets, and people to exist. What makes this idea unsettling is how it challenges our sense of uniqueness. For centuries, humanity believed Earth was the center of everything. Then we learned it was just one planet among many orbiting the Sun. Later, we discovered our Sun is just one star among billions in the Milky Way, which itself is just one galaxy among billions more. The multiverse theory takes that humbling process even further. Our entire universe may be just one bubble in an endless cosmic foam, no more central or special than a single grain of sand on a beach. But can we ever prove it? That's where things get tricky. By definition, other universes might be separated from ours by vast gulfs of spacetime we could never cross. And yet, some scientists believe subtle evidence may already exist. If two bubble universes ever collided in the distant past, they might have left behind faint scars in the cosmic microwave background, the radiation left over from the Big Bang. Researchers have even looked for unusual cold spots or anomalies in this background radiation as potential fingerprints of such collisions. The results remain controversial, but they keep the possibility alive. Then there's the idea of higher dimensions. According to string theory, the universe may have far more than the three dimensions of space and one of time we can perceive. Extra dimensions could provide pathways to other universes, hidden from us but intertwined with our own. If that's true, parallel worlds aren't distant at all, they could exist right next to us, separated by a veil so thin we can't detect it. Even more strangely, some physicists suggest black holes might act as gateways to other universes. When a massive star collapses, it creates a singularity, a point of infinite density where the known laws of physics break down. Some theories propose that instead of destroying matter, a black hole could funnel it into another universe entirely. If so, every black hole could be a portal, and our own Big Bang might have been born from a black hole in another universe. The deeper you explore, the harder it becomes to draw a line between science and speculation. Yet what makes these theories powerful is that they emerge naturally from equations that already describe our universe. Scientists didn't invent the multiverse just to sound mysterious. It's a serious attempt to answer real puzzles. Why does our universe have the exact conditions needed for life? Why does it exist at all? Why does it feel like the cosmos is fine-tuned for our existence? If infinite universes exist, then the answer might be simple. We just happen to live in the one where conditions were right. Parallel universes could exist because reality itself demands variety. And the more we learn about cosmology, the more that possibility seems less like science fiction and more like an unavoidable consequence of the universe's very structure. But if parallel universes are real, whether through quantum branching or cosmic bubbles, then one question still lingers. Will we ever be able to cross over? If parallel universes are real, then reality is far stranger than we ever imagined. Every decision, every random event, every twist of fate could be spawning countless new versions of existence. From the quantum world where particles dance between possibilities, to the vast cosmic stage where bubble universes inflate and drift apart, the multiverse isn't just a wild theory. It could be the true nature of reality itself. The unsettling truth is that we may never have absolute proof. Other universes might always remain beyond our reach, hidden by cosmic boundaries we cannot cross. But that doesn't make the idea less powerful. In fact, it forces us to rethink what it means to be alive right here, in this particular universe. Out of infinite possibilities, you are here now, living this version of reality. And maybe that alone makes this universe, your universe, more meaningful than we realize. So, whether the multiverse is fact or fiction, it invites us to look at the world with fresh eyes. Because if parallel universes could already exist, then the greatest mystery of all might not be out there, but in the very fabric of reality surrounding us. Don't forget to subscribe for more deep dives into strange